Okay, I think we are live. So let's see how this goes. With a little luck, this will work for the first day. Yes, we're all in seclusion, quarantine. So here's the first day of quarantine, 3/17/2020. Hope everyone's well. So what we're doing in this entire chapter deals really with x squared and now even x cubed. So what we're going to deal with next is square roots section. By the way, this is section 41A. Square roots, and believe it or not, we're going to do cube roots as well, etc., etc. So before I even start, let's take a look at what we already know. So these are perfect, what I call my perfect square numbers. And I'm going to list them. You probably know them, hopefully you know them. Okay, these are special numbers. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and they keep going, 169, so forth and so on. So these are perfect squares because they have square roots. We know the square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, square root of 100 is 10, square root of 121 is 11, square root of 144 is 12, and it goes on and on, 169, so forth and so on. So we need to know these numbers, okay? And we also need to know what we call our perfect cubes. So our perfect cubes are 8, that's 2 times 2 times 2, 27, 3 times 3 times 3, 64, 4 times 4 times 4, 125, that's 5 times 5 times 5. Let's see, what's 4 times 4 times 4? I think it's 216. Oh, let me grab a calculator while you guys are working on that. I'm pretty sure it's that. Nope, you're on your own. I'm working. You gotta make your own case again. The world recording. I'm back. Had to find a calculator, but I'm pretty sure that if I went 4 cubed, yeah, 64, boy. That's 4 cubed on this? Okay, no, I got that one. 2, 3, 4, 5. Oh, it's 6 cubed. Okay, there's 216. 216. 7 cubed is 343. 8 cubed is 512. And even, I guess 9 cubed, that's pretty big, but 9 cubed is 729, okay? Okay, so these are perfect cubes because the cube root of 8 is 2, cube root of 27, cube root, so forth and so on. Anyway, so let me start with an example, okay? So here's what our homework's going to be about, and here's what our lesson's going to be about. So example 1. If we get the square root of 20 on a calculator, the square root of 20 is a really ugly number, okay? Square root of 20, okay? So we get, square root 20. We get about 4.472, and that's an irrational number. So that decimal never ends, keeps going on forever and ever and ever, but we don't want that answer. So what we want to do is reduce the square root of 20, okay? So since it's a square root, we're going to try and reduce it. So we're going to reduce this by trying to find multiples, okay? We're looking for multiples. Multiples of 20 that happens to be one of these. Well, I mean, 2 times 10, no, because there's no square root of 2. Let me write that down. So what times what makes 20? Square root of 2, square root of 10 is not a good combination because there's no square root of 2 that's a good number, and no square root of 10. So I'm not going to do that, but I am going to use the square root of 4 times the square root of 5. Okay? So I'm looking for two numbers that multiply to make 20, one of which must be a perfect square. Okay, so what's the square root of 4? That's easy. So I take the square root of 4, that's going to become 2, and the square root of 5 is an ugly number, so we leave it. If you take square root of 5, I'll show you for sure, square root of 5 is, yeah, ugly number. So just that is my answer. So what I've done is I've taken the square root of 20 and I've reduced it. So these two numbers have the same value, but this is a smaller version of it, and this pays off later. Okay, so let's do another example. Okay, let's look at example number 2. Okay, so example number 2, I'm going to write 3 square roots of 18. All right, go ahead and write that down. So the 3 is a regular 3. It's not a square root number, so it is part of the question, but I'm not going to do anything with it, so I'm going to rewrite it as 3. But the square root of 18 can be reduced, so I'm looking for special square root. So 9 seems to be a pretty good choice. So I'm going to rewrite this as the square root of 9 times the square root of 2. 6 and 3 is a bad combination because there's no square root of 6 or 3. Now I can take then the square root of 9, I can reduce that down. So before I do that though, this 3 right here is still there. The square root of 3 is going to be regular old 3, square root of 9, I'm sorry, square root of 9 is 3, times square root of 2, which again is an ugly number. Leave your ugly number. So 9, I get 3 times 3 is 9 times square root of 2, and that is reduced. So my original question and my answer have the same value, but this is reduced. I get as much out of the square root as possible. Okay, let's look at example 3. Okay, example 3. So example 3, we can even look at it like a fraction. Okay, so if we had, oh, I want to do one more of these. Never mind, I want to do one more. I'm going to go 5 square roots of, say, oh, let's go something like maybe a 48. Okay, let's do one more. So the 5 is a regular 5. Leave it alone. Square root of 48, believe it or not, the best combination is 16 times 3. You could also do 4 and 12, but then you'd have to break down the 12 again into 4 and 3. So this is faster. Okay, so what times what makes 48? I like 16 times 3 because 16 is a perfect square root. It's right there. I like that. So I can take the square root of 16, leave the 5 where it's at. The square root of 16 becomes a 4. So instead of a square root of 16, it's a regular 4. Instead of the square root of 16, it's a regular 4. Square root of 3 can't be done. It's an ugly number. Leave it as the square root of 3. Then I have 5 and 4. 5 times 4 is 20. Square root of 3. Okay, that's my answer. So these two, the question and this reduced answer, have the exact same value, but this is a better answer. Okay, now you can also do this with fractions. Okay, so let me give you 2 examples with fractions. Okay, first example. Okay, if I had the square root of 9 over 16. Okay, the square root of 9 over 16. Well, what I want to do is create 2 problems, a top problem and a bottom problem. So I'm going to rewrite this. Square root of 9 over the square root of 16. So now it seems pretty easy. Don't look at it as a single fraction, but as the square root of 9, which is easy, that's 3. Square root of 16, which is 4, that's easy. Okay? Piece of cake. Okay, let's look at the next fraction example. Okay, example 4. So example 4, if I have the square root of 32 over the 25, as a single fraction, that looks kind of complicated, but we can fix this. Okay, so square root of 16, I'm looking at 32, and I'm going to rewrite this as the square root of 16 times square root of 2. I like 16 because that's a perfect square root. And the square root of 16 is 4, and I'll do that in just a second. And I can recreate this as the square root of 25. So I no longer have it as one fraction, but as 3 parts. Now comes the easy part. Square root of 16 is 4 times the square root of 2 over the plain old 5. Okay, this 2 is an ugly number. Square root of 2, it is just an ugly 1.41, so you'll leave it like that. Okay. All right, now what about variables? Well, let's take a look at this. Okay, if I had x cubed times x cubed. Okay, let's look at variables. X cubed times x cubed would be an x to the 6th. Or, since there's 2 of these, if I took the square root of x to the 6th, I know the answer has got to be x to the 3. So, because there's an invisible 2 here, what I want you to remember is it's like 2 1/2 power. So I want you to take half of your exponent. So if you take half your exponent, it goes straight to it. Okay, so let's look at another example. If I had the square root of x to the 10th, it's easy. take half your exponent. Rewrite that as x to the 5th. Done. Because x to the 5th times x to the 5th does make x to the 10th. Hopefully this seems easy. Now, what I've done is used numbers that were divisible by 2. What if I get something like this? Example, what if I had the square root of x to the 13th, okay? Now, I don't want a decimal answer, so what I'm going to do is this. I'm going to reduce this first. I know I'm going to take 1 away. Take 1 away, and I'll rewrite this as square root of x to the 12th times the square root of x to the 1, okay? Take 1 away. Take 1 away from the exponent, so instead of 13, so if it's odd, we need to make it even. So if it's odd, we need to make it even. So what did I do? Took an odd number, an odd exponent, took 1 away, made it x to the 12th next one. Now this one I can take half of. So I'm going to take half of that. It's going to give me an x to the 6th, plain old x to the 6th, because I took the square root of it. And then this square root of x to the 1 has to be left alone. Okay? Hopefully you're not confused. Go back and watch it again if you want to, okay? Now, let's combine these two types of problems. Okay, let's make it an example like this. Let's do something like the square root of 18x to the 13. All right, let's combine both. So when I look at this problem, I see 4 parts. Actually, to start off, I only see 2 parts, but I'll show you what I mean. I see 2 things. I see numbers, square root of 18, and I see variables x to 13. So I see 2 parts. So let's rewrite this. First of all, 18. What times what makes 18? What times what makes 18? How about 9 and 2? Square root of 9, square root of 2. Okay? I like that because I can take the square root of 9 and get 3. That's an odd power. So let's take 1 away from it, just like we did up here, and make it x to the 12th times an x to the 1. Okay? So what I did is I tried to make it so that in this mess I had something that I could take the square root of. In this mess I made something I could take the square root of. So square root of 9, boom, that's going to be a 3. Can't do anything with the square root of 2. If I take half of my exponent, I'll get x to the 6th, so I'll get a 3, x to the 6th. Square root of 2 cannot be done, and square root of x cannot be done, so they just stay put together. Okay, I've got one more thing I want to show you, and then I'll be done. Okay, I'm going to turn the page. This isn't taking that long. We'll be done before 15 minutes over, maybe. Okay, last example is a cube root. If I had the cube root of 250 x to the 6th. Alright, I'm going to do this the same way. I'm going to look at it as the cube root of 250 times the cube root of x to the 6th. Okay, cube root of 250. Let me go back in my notes for just a second. Let me go back in my notes. Hold on. And here's my perfect cube roots. Now, 125 times 2. 125 times 2 makes 250. That's a perfect cube root. Okay, so I'm going to go back and rewrite this as the cube root of 125 times the cube root of 2. I took half the exponent, but this case I'm going to take a third. 1/3 of my exponent. Okay, so I'll take a third of that, which makes just an x to the 2. Almost done. I know what this is. The cube root of x. Cube root of 125 we know is 5, because 5 times 5 times 5 is 5. This x squared is done. It goes out in front of it, times the cube root of 2. Okay, now, if you have a good calculator, your good calculators will do square roots. Okay, good calculator will do square roots. You can do square roots of, say, 144. And it will also, if you go to the math button, it'll also do cube roots. 125, okay? Some of the phones will do it too, but you guys can just work on this. Okay, so here's your homework. Okay, you're going to go to page 113, I'll write this down. Page 113, and I want you to do the 1 through 12 all. Okay? So if you have any questions, just email me or text me or whatever. So I want you to do page 113 out of your journal. And I want you to do 1 through 12 all. This will be a 2-day lesson. So this is part A, or part 1. All right. Hopefully you're with me and understand what's going on. But keep me posted if you're not.